Right now, in this exact second, a machine built by human hands is moving through the dark at over 60,000 kilometers an hour, carrying a golden record of our voices, our music, our laughter, toward a future so distant that the sun will have died long before it arrives anywhere close to another star. Scientists have actually sat down and calculated where this machine will be. Not in 100 years, not in 1,000, in 10 trillion years. And what they found is stranger, lonelier, and somehow more beautiful than anything science fiction ever imagined. This is the story of Voyager 1's final journey, the one that doesn't end when its power runs out, the one that keeps going long after Earth, the sun, and everything you have ever known has stopped existing. Let's start with what we actually know for certain, because even the near-term future of this spacecraft sounds like something out of a myth. Voyager 1 launched on September 5th, 1977, and used the gravity of Jupiter and Saturn to slingshot itself out of the solar system entirely, onto a trajectory that no planet, no star, and no force we currently understand is capable of stopping. It is not orbiting anything. It is not coming back. It left on an escape trajectory, meaning the sun's gravity, weak as it already is at this distance, will never be strong enough to pull it home again. Voyager 1 is currently more than 25 billion kilometers from Earth, traveling at roughly 61,000 kilometers per hour, and every single year it gets about 3.5 astronomical units farther away. It is not heading toward any particular star. It was never aimed at one. Its path was set by the accidental geometry of 2 gravitational slingshots performed decades ago, and from that point forward, physics has simply been carrying it forward in a straight, unbending line through the galaxy. But here's where the story stops being simple. Because even though Voyager 1 wasn't aimed at anything, the galaxy is not empty, and it is not still. Stars move. Our solar system moves. Voyager moves. And astronomers, using precise data on the positions and velocities of nearby stars, have actually been able to calculate what happens when those moving paths start to intersect. In about 40,000 years, Voyager 1 will have its first real brush with another star system. The star is called Gliese 445, a small red dwarf currently sitting about 17 light years from our sun. Right now, Gliese 445 is essentially just another faint point of light in the constellation Camelopardalis. But it is moving toward our solar system at roughly 119 kilometers per second, closing the distance far faster than Voyager itself is moving away. By the time the 2 paths draw closest, Gliese 445 will have drifted to within about 3.5 light years of where our sun currently sits. And Voyager 1, riding its own quiet trajectory, will pass within roughly 1.6 light years of that star. To put that in perspective, 1.6 light years is still an enormous distance, more than 9 trillion miles. Voyager won't enter that solar system, won't be captured by its gravity, won't see anything resembling a close encounter in any dramatic sense. But by the strange bookkeeping of interstellar space, where nothing is ever truly close to anything else, this will be the nearest Voyager 1 comes to another star in the deep future that anyone has been able to calculate. Of course, by the time that moment arrives, 40,000 years from now, Voyager 1 will already have been silent for a very long time. Its plutonium power source, the radioisotope thermoelectric generator converting the heat of radioactive decay into electricity, is expected to keep providing at least some usable power only until sometime around the year 2036, give or take, depending on how carefully engineers manage to stretch what little is left. After that, the instruments stop. The transmitter stops. The faint patient signal that has been crossing the solar system for nearly 50 years finally goes quiet, and Voyager 1 becomes, in the most literal sense, a dead machine, not destroyed. Not disintegrated, just silent. A cold, inert shape drifting through the vacuum, carrying its golden record and its dormant instruments into a future with no one left to listen. And this is the part that tends to stop people in their tracks. That silence does not mean the story ends. It means the story simply continues without us watching. Because a dead spacecraft in interstellar space does not decay the way objects decay on Earth. There's no atmosphere to burn it up, no water to rust it, no bacteria to break it down, no gravity while pulling it toward a fiery re-entry. Interstellar space is close to a perfect vacuum, and Voyager 1, once its power dies, will essentially become a solid, silent artifact, subject only to the extraordinarily rare chance of colliding with something else, or the almost imperceptibly slow erosion caused by the occasional grain of interstellar dust striking its surface across unimaginable stretches of time. Scientists who study the long-term fate of spacecraft on escape trajectories have actually tried to put a number on how long an object like Voyager 1 could physically persist, structurally, before something destroys it. That number is so large, it becomes almost meaningless as a lived experience, so let's translate it. That is roughly 7 billion times the current age of the universe. The universe itself, as we currently understand it, is about 13.8 billion years old. Voyager 1 could, statistically speaking, keep drifting through the galaxy for a length of time that dwarfs the entire history of the cosmos so far, many times over, before the ordinary hazards of interstellar space ever catch up with it. Which brings us to the question in the title, because 10 trillion years is a real number scientists actually use when discussing the far future. And it is worth understanding exactly what that number means before we place Voyager inside it. 10 trillion years from now, almost everything you would recognize about the universe will already be gone. Our sun, a fairly ordinary star, is expected to exhaust its hydrogen fuel in about 5 billion years, swelling into a red giant that will likely engulf Mercury and Venus and scorch whatever remains of Earth beyond recognition, before collapsing down into a slowly cooling white dwarf. Long before Voyager reaches anything resembling its 10 trillion year mark, the star that gave it its journey's starting point will have died. Around 4 to 5 billion years from now, our entire galaxy, the Milky Way, is expected to collide and merge with its neighbor, the Andromeda Galaxy, in a slow gravitational dance that will completely reshape the structure of the night sky, flinging stars into new orbits, triggering waves of new star formation, and eventually settling into a single, larger elliptical galaxy that astronomers have started calling Milkomeda. Voyager 1, by then just an inert fragment of metal and gold-plated copper, will be swept up in that merger like a single grain of sand caught in the collision of two oceans, its trajectory nudged and reshaped by gravitational forces on a scale that makes anything humans have ever built look genuinely insignificant. Keep going. By around 100 trillion years from now, the era of active star formation across the entire universe is expected to end. The vast clouds of hydrogen gas that once collapsed to form new stars will have been used up or dispersed, and the last stars still burning will slowly wink out over the eons that follow, leaving a universe increasingly dominated by white dwarfs, neutron stars, and black holes, cooling and fading into darkness one by one. This period, sometimes called the degenerate era by cosmologists, is where the number in your title, 10 trillion years, actually sits. It falls before that final darkening is fully complete, in a universe already noticeably dimmer and emptier than the one we know, but still containing scattered, slowly cooling stellar remnants drifting through what has become an overwhelmingly vast and increasingly empty cosmos. And somewhere inside that unimaginably dark and quiet universe, according to the physics we currently understand, Voyager 1 is very likely still there. Still intact, still carrying its golden record, its images of Earth, its recordings of human languages and human music, sealed against a vacuum that has nothing left in it capable of destroying it. It is one of the strangest conclusions modern astrophysics has produced, and yet it follows directly and soberly from the numbers. A machine built in the 1970s by engineers working with slide rules and punch cards, designed to survive a 5-year mission past Jupiter and Saturn, may end up being one of the most durable objects humanity ever creates. Not because we built it especially well, but because the emptiness of interstellar space is simply that forgiving. There's almost nothing out there to break it. Of course, none of this is certain in any absolute sense, and it's worth being honest about that. Predicting the exact motion of any object over spans of tens of thousands of years, let alone trillions, involves real uncertainty. Because the gravitational influence of every star, dust cloud, and structure Voyager eventually passes near will nudge its trajectory in small ways that compound over deep time. Astronomers can calculate close approaches like the Gliese 445 flyby with reasonable confidence, because that timescale, 40,000 years, is short enough that stellar positions and velocities are still fairly predictable. Beyond that, the picture becomes probabilistic rather than precise. Scientists aren't claiming they know exactly which stars Voyager will drift past a billion years from now. What they are confident about is the broader statistical picture, that interstellar space is so overwhelmingly empty and stellar collisions so overwhelmingly rare that an object moving through it on an escape trajectory has an extraordinarily high likelihood of simply continuing to drift, largely undisturbed, for a length of time that our species has no real intuitive framework for understanding. There's something worth sitting with in that. We built something whose most likely fate is not destruction, but permanence, not a fiery ending, but an almost eternal, silent drift through a universe that will look less and less like the one we currently live in with every passing epoch. It will outlast every civilization that has ever existed on Earth, if human civilization does not itself find a way to endure. It will outlast the Sun. It will outlast the Milky Way as a distinct galaxy. It will very likely outlast every star currently visible in tonight's sky. Long after the last recognizable trace of Earth has vanished, long after the very stars have begun to gutter out one by one across the universe, a small, cold machine carrying a phonograph record and a needle and instructions written in mathematics for anyone who might one day find it will still be out there. Not moving toward anything, not moving away from anything, in any sense that would matter to it, just continuing, the way physics allows a lone object in a nearly perfect vacuum to continue for what our current models suggest could be trillions upon trillions of years. It's easy, hearing a number like 10 trillion years, to feel it as something cold and abstract, too large to actually mean anything. But there is another way to hold it. Every single person who has ever lived, every language ever spoken, every song ever written, existed within a sliver of time so small compared to what Voyager 1 may experience that it barely registers on the scale we're describing. And yet, a fragment of all of that, deliberately, carefully, is riding along with this spacecraft into that unimaginable future. The golden record was designed by Carl Sagan and his team specifically with this kind of timescale in mind, engraved rather than printed, using materials chosen because they would resist decay far longer than paper or film ever could. They built it, quite literally, for eternity, or at least for something close enough to eternity that the distinction stops mattering. They did not know in 1977 that the calculations we can now run would suggest their message in a bottle might actually survive for trillions of years. But in a strange way, that was exactly the bet they were making. 10 trillion years from now, there will be no one left to press play. No civilization to intercept the signal. No eyes to read the diagrams etched into that golden disk unless, against every reasonable expectation, something finds it first. And that is perhaps the strangest, most human part of this entire calculation. We built something meant to be found and sent it into a future so distant that finding it becomes almost a metaphysical question rather than a scientific one. Voyager 1 will drift on, past dying stars and colliding galaxies, through an era when the universe itself is growing darker and colder with every passing age, carrying inside it the sound of a mother's heartbeat, the greeting of a child, a fragment of Bach, a photograph of a species that no longer exists anywhere else in the universe by the time anyone, or anything, might ever come close enough to notice it. We tend to think of our achievements in terms of decades, careers, generations, centuries at the outer edge of ambition. Voyager 1 quietly broke that scale the moment it left Earth, and the calculations scientists have now run only confirm how far that break really goes. It is entirely possible that the most enduring thing humanity ever makes is not a monument, not a pyramid, not a language, but a small 47-year-old spacecraft drifting silently through the space between the stars, still traveling long after everything else we have ever built or loved has returned to dust.